This call is now being recorded. This call is now taking notes.
All right, welcome to class, everyone. Young innovators, welcome to class. I'm glad to have each and every one of you. So today we'll be starting our very first mission in our mathematics track, and that will be the mathematics of discovery, right? And it's important to understand that every great innovation begins with curiosity, and it's very, very important for you to take note of that. All right, so we're looking at the maths track today, and the heading for today is simply the mathematics of what? Of discovery. So let's walk it down. We should have taken our student pledge, but because of time, we're not taking our student pledge today. All right, if time permits, towards the end of the class, we'll take the pledge. So what are we going to achieve today? So for today's lesson, we are going to observe. All right, we observe. We're going to ask questions. We're going to measure. We're going to understand, and then see how best to solve problems. So for today's goal, we're not solving math questions. All right. So today is that we want you to think like an innovator. It is not about, you're not solving any math. We are solving a math problem, but not the kind of math everybody's thinking about now. I know everybody's expecting, let's start solving math questions and the rest of them. But that's not the kind of mathematics we're going to do today. We're going to do 5 key things. We're going to observe something. We're going to look closely at a particular thing. We're going to ask questions. That means we're going to stay curious. Then we measure a problem. Then we understand. We'll build an evidence around whatever thing we understood. And then we can use that to solve a problem. All right. If you're still with me, can you give me a thumbs up before I proceed? I want to ensure everybody's with me. Beautiful. So let's keep going. Let's keep going. It's going to be a very brief session, but then just ensure you are following through. All right. Thank you, everyone. Now, I have a question, and I want you to type on the chat now. It would have been a poll, but I think it's okay for me to have it on the chat so that we'll be active. All right. So for our friends that are new with us, welcome. We'll have new persons in our midst, and I think it's okay. We welcome each and every one of them. We have Chukwemeka is here, and the sibling is also there. I've forgotten the name, but we have Chukwemeka here, so it's good to welcome him as well. This is the first time joining our sessions. All right. So welcome, Chukwemeka. Welcome you officially to the Sismo STEM experience. Welcome. We're glad to have you. And your co-students and co-innovators in the house are so happy to welcome you as well. So feel free, ask questions as much as you can. We are glad to have you right here in our midst. Thank you. All right. So let's proceed with that particular question I have for everyone. So and let's see what your answer is. Which one is more important? Questions or mathematics? Which one do you think is more important? Is asking questions more important, or is mathematics more important? Ikechuku said questions. Chukwemeka questions. Nnamdi questions. Tidibem questions. Okay. Jane question. Chizi question. Asking questions about mathematics. Nicholas, I saw what you did there. Josiah said maths. Okay. Questions. Everybody saying question. Okay. I think we'll have more of questions right here. So can I want to call a name, all right? And I'm going to call just the last names I have here, and let me know why you are picking question to be the answer. Why do you think question is more important? Now, the first person that said question was Ikechuku. So Ikechuku, I want to hear from you. Why do you say that question is more important? And then I'll pick the last person that answered question. And that last person is Bamise. Okay, let's balance it. Yeah, that last person is Bamise. So why do you think, why did you choose question? That question is more important. And I have one person that said mathematics, and that is Joshua. So I want to see why you said that. So Ikechuku, your mic is now on. Go ahead. So why do you go for, what's your reason for saying question is more important? Let's see your point of view. Okay, just okay.
Because when you ask questions, you might be able to learn something new that's different from what you're learning, which can help you in the future.
Oh, beautiful. When you ask questions, you learn, which can help you in the future. I like that very that school of thought. Quite beautiful. And I agree with you as well. So Bamise, what do you have to say? The stage is yours, Bamise. So what's your own idea? Why did you say that questions asking questions is more important. All right. So let me say over to you. Then after that, we'll have Josiah.
I say questions because questions help me learn better.
Okay. Questions help you learn better than mathematics. Is that what you're trying to say?
No, like asking questions about it makes me learn better than
About
just
it.
seeing it.
Okay, than just seeing it. Okay. So that means what is now mathematics? This one we're separating questions and mathematics. I'm now curious to know. Don't we learn from mathematics? Okay, that's fine. Let me say both are important. Okay. I think I will call Lade soon. All right. So the next person is Josiah. Josiah, you said mathematics. So let me hear from your own point of view. Then I pick Lade. I think I have more of the boys. Then Claire. No, is it Claire? Yeah, Claire. I think is the last girl that commented. Or I'm going to call you soon. All right, go ahead. Josiah.
I was going to say mathematics because we can answer any questions. We can problem solve any questions that comes to our mind with an easy step instead of going on research and just out of thinking. So I was saying mathematics.
Mathematics, because it helps you solve questions. Is that what you said? In summary.
Yeah.
Yeah, that's a brilliant contribution. I also like that school of thought as well. All right. Because with mathematics, you will not be able to solve questions. Very brilliant contribution, Josiah. Continue like this, Josiah. Thank you. Then Lade, before I call Lade, let's hear a lady's voice as well and let's see their school of thought. So Claire, why did you pick question? Now we are all curious to know why you pick question.
I don't think maths is anything without questions because like all the mathematic formulas are like solving a question of why, like for example, Pythagoras theorem is like why does a right angle triangle work like this? So like I think everything in math solves a question.
Okay, I'm a bit confused. You said you went for question actually, right? You're citing the people of a question, right? So now I didn't get your point to actually support your motion for question.
Like maths is about solving questions. Like
okay, maths. Okay, it's about solving question. Then the question is about what?
Solving the maths.
I'm confused, Claire. You just confused me. You said that maths is about solving question. Then question is about solving maths. Is that what you said?
Yeah.
My God. Can you go a little bit further? Because am I the only one a bit confused? That's a powerful point, but I want to drive it home. Can you drive it home, please?
Like every formula in maths solves a question. So
Okay.
like questions are more important.
Wow. Every formula in maths solves the question. So then questions you now solve maths, right?
Yeah.
Can someone type that on the chat for me? This is Mr. Hillary. I hope you took note of that particular line. All right. Please, I know you're on the call today. We're happy to have you. All right. So I think we need to write it down. With maths, you solve questions, right? And with questions, you do what? Claire, did I get you correct now?
Yeah.
Okay, with questions, you now solve maths. Hey, you're powerful. I think someone should write that on the chat for me. Okay, then finally, before we move, let me say they're both important. With maths, you solve questions, and with questions, you solve maths. Okay. Mr. I want to pin this how will I pin this your comments now? Okay, let me comment it and pin it. Okay. Okay, we're going to make reference to this, but once again, later we'll make reference to this. Okay, I've pinned it. Since maths answer questions, without questions, there will be no maths. So, Claire, I think Prosper is supporting what you said. Prosper said, since maths answer questions, without questions, there will be no maths. Prosper, you are on fire right now. Are you aware? Claire, do you support what Prosper said?
Yeah.
Okay, is that what you're trying to say when that thing you say? Is that exactly what you wanted to say? Like, is that your thought as well? What Prosper said? Since maths answers questions, without questions, there will be no maths. Good. Lade, over to you now. I think you guys are in my heart at the moment. You guys are in my mind as it stands. So, Lade, over to you now so that you wrap it up now. And I'm glad to have you anyway. Adebisi is not here. Adebisi not here. Yeah, go ahead, Vladdy.
To be honest, question is like a general word, so I
Okay.
can't say any of it is important
Okay.
because question can be from English, science, math.
Mhm.
So they just work both. They both work hand in hand.
Okay, they work hand in hand. Okay. Now, but Claire, your mic is still on. Are you saying that they work hand in hand, or that question is more important, Claire?
Questions is more important because
important.
without questions there wouldn't be math. Like
Okay. Okay. Good. Prosper, are you choosing both? Prosper, type on the chat. Should I on your mic for you? Prosper, are you choosing both? Or you want to say something? Just type on the chat, Prosper. Prosper, you are there. I love your contribution. Okay, that said, we have 2 points here. With math, you solve questions. With questions, you solve maths. That's from Claire. Then Prosper said, since math answers question, without question, there will be no mathematics. So Prosper, what's your view? Which one are you going for? I want to get from you. I'm choosing both because I think question is more important. So with questions, you're able to learn a lot and solve math. Okay, let's go on and see what the answer is. Now, look at the real answer now. Both of them are important. So none of them is important on its own. They work together. And that's what you guys said. So I'm surprised at the end of the day, you guys still chose one of them. Like what Claire said. Claire said something. You said, I'm going to where I pinned it. You said, with maths, you solve questions. And with questions, you solve math. That means both of them are important on their own. Right? So now, look at what I wrote here, which is the same thing that you guys said. I said something here that questions gives mathematics a purpose. And that's what Prosper said. That's why I said you guys are in my heart. Prosper said something. Since maths answers questions, without questions, there will be no maths. I see it now, which means it is question that gives mathematics a purpose. Now, and then mathematics will now give question and evidence. Does it make sense at all? I don't know if it makes sense. People in the house, does it make sense at all? Yeah, because I love your contributions, which is very, very beautiful. And Prosper and Claire, that's why I love those contributions, and I pinned it on the chat. Those contributions are powerful. All right. So, because we know that maths will answer question, and if I don't have any question, there will not be maths to solve. So, which means that question will give mathematics a purpose. It is question that will give mathematics a work to do. And then with mathematics, after solving the question, right, we will now have an evidence and a result. Are you seeing it now? Does it make sense, guys? Everybody on the chat, Claire, Prosper, and everyone on the chat. I hope we are now on the same page. Yeah, all of us on the same page. Thank you. So it makes sense now. And I love your contributions. And that's why I said I love this class so much, because of the way you guys think. Very beautiful, very amazing. All right, so we've established something that both of them are important, and the other guys gives maths a purpose. Very beautiful, very amazing. All right, now I said something here. Without questions, mathematics has no direction. And without mathematics, questions remain unanswered. You ask question without having a response to it. Now, my friend Nnamdi said something. Nnamdi said, you learn more when you ask questions. But when you ask questions and nobody gives you an answer, will you still learn? When you ask questions without a response, will you still learn? No, it's not possible. Beautiful. So therefore, without question, mathematics has no direction. And without mathematics, questions remain unanswered. I think you should take note of these things. All right. I think you should take note of these things. Okay. So Claire, that's Sharon. Okay, that's a mistake. Okay. Now, let's now look at something else. One more question, and then we'll dive into what we have. Oh, sorry, I forgot a line right here. So we'll have mathematics questions, we'll ask questions, we'll have mathematics, then we'll have an evidence. With the evidence, we can now make better decisions, and then we innovate. So for today's lesson, we're going to move through questions, mathematics, evidence, And then tomorrow we'll look at better decisions we could make, and then we innovate. And we'll wrap up with a quiz for our session. So now, that said, I have one more question. Can mathematics solve problems? Can mathematics solve problems? Okay, Ugochukwu said yes. Children said yes. Amanda said yes. Claire said yes. Everybody saying yes, yes, yes. Okay, mathematics can solve problems. Mathematics can solve problems. All right. So I need someone that wants to defend the point that mathematics can solve problems. One person. Okay, I have the first person. Now let me pick the first person that said yes. Now, the first yes I have was Ikechukwu. You said yes first. So Ikechukwu, over to you. Then the second person that said yes for the ladies is Amanda. So Amanda, over to you. So you see why I'm picking you guys. First yes from the male, first yes from the female. So Ikechukwu said yes first. So go ahead and let me. You are now the co-host, and Amanda, you are also, your mic is on now. So go ahead and talk. Where is Amanda? I'm looking for. So go ahead, Ikechukwu. So why did you say that math solve problems? Let's hear your school of thought.
It's because maths is a key factor in lots of things like building, science, and lots of other stuff too. And without it, then doing stuff like that would be much harder than it is with maths.
Okay, with maths. Okay, you said with maths. Okay, I like that keyword. So somebody take note of what you said. With maths, we could solve some of those problems. Beautiful. You said with maths. Very amazing. I like that school of thoughts. Amanda, over to you now.
I think as long as you know the problem, maths can solve it, because it
Okay.
makes logical solutions for the problem. But you can analyze stuff in maths and try different outcomes till you can get the solution.
Okay. So, which means, are you saying that all of us we are revolving around the same thing? And that makes a lot of sense. Good. So, if you have a problem, that means maths can solve it. But I think you guys are making reference to something, but there's something we are missing, brethren. We are missing something very important. All right? Yeah, there's something we're missing, and I want to talk about that which we are missing in terms of this. But remember, you guys, everybody's on point with their school of thought, and I like that school of thought. The same thing, we're making reference to the same thing. But now, what if I tell you that this might sound somehow, it is not math that solves the problem. Now, Anikechukwu said something with. Amanda also said something with as well. And I'm holding on to those two words you guys used. And those two words will reveal the next thing I have to say. Now, the next thing I have is that mathematics cannot solve problem on its own. It is people that solve problem. But then we use mathematics to solve the problem. Does it make sense now? So mathematics, or if you say math solve problem, how? It is someone that will have to apply that. Are you getting it now? So maths cannot solve problem, but it is people that solve problem, and mathematics is now one of the tools that they use to solve the problem. Because if you look at when you ask questions now, mathematics is just there. It needs me, it needs you. Even Amanda mentioned it, and Ikechukwu. People, scientists, and that, and the rest of them could come together to now use the mathematics as a tool to solve the problem. Just like my brush on its own cannot brush my teeth. If that happens, I wake up in the morning and then I see my brush brushing I will run away from the house. Is that not strange? Let's say you just wake up in the morning, notice that your brush is already, brushing your teeth. You are lying down on the bed, and then you are going to run from that particular house because it is not normal. Are you seeing it now? So the brush on its own is a tool, but it needs someone to hold the brush to do what? To brush the teeth. That's the same thing that happens right here. So math on its own by itself cannot. But people solve problems, and mathematics becomes one of the most powerful tools that they use. Take note of that keyword, powerful tools. Both civil engineers, they make use of it. Doctors, urban planners, environmental scientists, everybody make use of mathematics. So in school, when you say you don't like mathematics, it simply means you don't like solving problems. So that's a mindset I want to sustain, and that's why I'm going through all of these things. That when you say I hate mathematics, it simply means you hate solving problems. And from the beginning of our lesson, we said something that the world has problem, and the world also have what? Problem solvers. And I am one of them. That was one of the pledge you made. So for you to be a problem solver, you must be someone that is in love with mathematics. Someone will start thinking, now what is even this mathematics I'm talking about? Does it have to be those equations and the rest of them? And then they said, sir, does it have to be those equations I'm talking about? Is that the only mathematics? Is that what comes to your mind? Is it the right angle triangle that comes to your mind when it comes to mathematics? But mathematics is beyond the equations and the rest that you think about. And that's one of the key things we're going to be looking at today. Now, let's now see how mathematics can help us solve a real problem. In life, you need mathematics. In everything you do, you need mathematics. Mr. Hillary will tell you as well that when they are writing programs, I hope he's on the call, when they are writing programs, Mr. Hillary here now, when you are writing programs and code, for example, when you guys were building the parent report of SISMO, did you guys apply mathematics or not? Mr. Hillary here, let me just turn on your mic a bit so that people will get to understand that mathematics is something we need for life. Are you here? Yeah, your mic is now on, sir. So when you were building the parent reports, even this particular site, when they sign up on the website, was there a need for mathematics at all? Is Hillary there? Hello? Is he on the call? Yeah, I don't think, is he here? Oh, I wish he was here. Okay, he is, right? Okay. I think he needs to tell us maybe just one or two things. While we wait for him, I need to hear from him so that you could see that there is an application to all of this. When they were building the site, whether they used even the sign-up form, even the dashboard that we are signing up on, it has to do with that. But even if you don't like mathematics problem, it doesn't necessarily mean you don't like problems. So you are still seeing mathematical problem. I want to change that mindset. It's not about mathematical problems. So when they say mathematics, don't start thinking about those equations you have, in the house and the rest of them when you go to school. So start thinking about it in different ways. Are we together now? Even your science cannot function without mathematics. So I'm heading somewhere. Just follow me. Now, let's see how mathematics can help us solve a real problem. Are you there now? Let's see how mathematics can help us solve a real problem. So, I don't want to start thinking about equations. Don't think about equations now. Because when you're solving real life problems, you're not making use of that equations. When you have decisions to make, you don't really make use of those equations. So stop thinking about equations at the moment. Just open your mind and follow me. Now, let's look at a case study. In that case study, I just created something, mathematics problem, and made it turned into analytical structures. Beautiful. That's what I am, like I said, mathematical problems are very real life problems turned into analytical structures. So start thinking that way, that you need mathematics even to make decisions. Now, is that clear now? Is it okay now? So don't think it's about mathematical problems. It's because you're here to understand where to apply those mathematical problems. All right, so let's continue. Let's look at a case study. So now, I hope I'm not missing out anybody. The whole class, you guys are following me. Should I start calling names? I hope you are following. Ikesh, could you have a question? Ikesh, your hands are up. Okay. Josiah Masoko, that's Mary. Hope you are following. Nicholas Ugo, hope you are here. Namdi, Ugochukwu, Nicholas as well. And then you see Sharon, Zikora, my bro. And Jane, Claire, hope you are here. Chukwemeka, I hope you are following together with your little brother. Hope you are following. Chizi, Tim Harida, Prosper the Man, Chizi, Tim Bamise, Lade, Amanda, Abigail, Ugu. Yeah, I hope that everyone is following right here. Beautiful. So let's proceed now. So look at this case study. Welcome to SISMO Academy. Now, this is an academy, just a case study. And in this academy, this is where curiosity grows, ideas skyrocket, and young people build a better future. they have different classes, 4 categories of class they have. The same way you have year 7, year 8, year 9, year 10, year 11. But in this their academy, they have 4 different categories for the students. So each category have their own classroom. Now, the first people are the young explorers. The young explorers are between the ages of 7 to 9, and there are 18 students in that class. We have the young innovators, and their ages is ages 10 to 12. There are 25 students in that particular class. We have the future engineers. That's the name we'll give to them. I believe in your school, some classes have their name, right? When I was in school, we had JSS1A here in Nigeria. So I think year 7, you do it in sets, set 1, set 2, set 3, right? For some of those in UK, you have your sets, right? So that same way, in this academy, they have different names for the different classes, all right? So we also have the young leaders. They have 15 students in that class, and the ages of the students are from 16 to 17. Follow this, our analogy properly, follow the way we are moving for this particular problem. Now, you look at the school, everything looks perfect, right? You could see the solar panel right there. Can you see that now? You could see the solar panel right there, right? You could see the waste properly arranged. You could see flowers. The school, it looks perfect, right? It looks perfect. Yes or no on the chat? It looks perfect, right? It looks nice. Yeah, good. You can type on the chat. Yes, it looks nice. And then we have different categories of students, like I've mentioned. Take note of the age range of the students. Take note of the number of students in the class. Now, however, over time, one of the persons in charge of the school now had an issue. A report was given. Look at that. The incident report was given in the school that over the last few weeks, the cleaning team has noticed an increase in the amount of waste produced across Sixmo Academy. And every afternoon, they collect much more rubbish than before. So, Engineer Lothar knows that there is a problem, but he doesn't know the class that is responsible. The number of waste is increasing every single day, and that's a problem. It became unusual in the school. You could see the picture we painted right here. And then one of the teachers in the school, or maybe one of the school, became concerned. You know, he said, "What could be the problem?" He knows that there is a problem here in this school, but he doesn't know which class is responsible. Is it the young explorers? Is it the young the future leaders? Is it the young innovators? Which particular set of students are causing this problem? Remember, we highlighted the number of students we have in each class, and we are confused as from which class is this waste coming from. We know some students are responsible for the increase in the number of waste in the school all of a sudden. So we want to know the school that this thing is coming from. Now, assuming that you are Engineer Lothar, what should you do? Or what will you do? Or what will you advise Engineer Lothar to do? Which people, yeah. What should Engineer Lothar do to actually find out the number of students that are doing this? What can you do? And which particular people do you think are doing this? You can type on the chat. First of all, let's know those that are doing this. All right? Let's know. I want to hear your view. So I went to the young, to further explain the problem. I went to the young explorers class, the ages of 7 to 9. They said it wasn't them, that their hands are clean. I went to those of the young innovators, and they said they are very careful people between the age of 10. They said, no, it's not them. All right? Now, the future engineer said, we think it is the young leaders. It is not us. Then the people between the age of 16, 17 says, everyone is always blaming us. Now, which class do you think is producing the most waste? Which people produces the most waste? Young innovators. Why are you thinking it's young innovators? Everyone is saying young innovators. What's the reason? They clash with the most people. Okay, I'm pinning some key things now. Chizzy said the class with the most people. Okay. The 3 more of them. So Chizzy said the class with the most people. Okay. Three of. I want more people to say something. Just there's no right or wrong answers. Which class is responsible for this? Young explorers. So why are you guys calling young innovators and young explorers? Okay. Jane, what's the reason for young innovators? Due to probability, it will be the youngest class. Okay. Okay. Namdi, why pick young explorers? Jane, why pick young innovators? I want to hear from you guys. I'm calling up these people now. Jane, you tell me why you are picking the young innovators. Chizzy, you tell me why you think is the class with the most people. Then Namdi, you tell me why it is the young explorers. Okay, so let's go. I will do that simultaneously. I will turn on all your mics together. So Jane, over to you now. After Jane, I want to hear from Chizzy. Then after Chizzy, I want to hear from Nnamdi. So why are you guys picking those people? Very fast, then we'll continue. Everybody's saying, okay, Jane, over to you. So why did you pick, I think it was young, I don't know the people you picked again. So over to you. And that's after that, okay.
I think it's the young innovators because of there's more of them, and sometimes young innovators are irresponsible and stuff like that. I don't really know much, but I know that there's more of them.
Oh, beautiful. Okay, I agree. Okay, that's fine. Chizzy, over to you now.
I said the class with the most people because
Okay.
if you have more people, like for example, if you have more people in a household, then your household's going to produce more waste than all the other households in your neighborhood because there's more people who use up more resources. So that's what I was thinking.
Okay, beautiful. All right, so I think we'll have different things right here and different people saying different things as well, and that's entirely fine. And let's proceed and see what happens. All right, now let's move on and let's see. Now we'll have opinions and different. Are we going with opinions or evidence? People will say younger children will make more mess. That's what people are trying to. Some people are trying to say older students eat more food, bigger class produce more waste. That's exactly what Chizzy just said now. And I think Nancy was trying to say that some of those people will produce more. Teenagers buy more snacks. But all these things are facts, isn't it? And these facts are assumptions, right? These are more of opinions than evidence. Right? So these are the assumptions we are making. So how do we now verify to discover the truth? What do we do to discover, assuming that you are Engineer Lota now, what are you going to do to discover the truth? What will you do? All right? Yeah, what will you do? Get each class to push their rubbish in different bins and see the class with the most waste. Okay? Find evidence. Thank you, Claire. Claire said, get each class to put their rubbish in different bins and see the class with the most waste. Now, is this something, Claire? Find evidence. Okay, I have Claire now. Claire, how will you do that? Let's say we'll find a bin for them to put their rubbish. Is it for a day? How do you want to actually get that done? For you to get for each class to put their bins in different and then see the class with the most bin. I think the mem said that as well. Chidibem said something about put waste bin in front of every class and see which one gets filled first. It's not about the one that okay, let's see. If it happens that day, there's tendency that our own might fill for the first day. Let's assume that you did that. It might be that we are not the person doing it. But for that particular day, for some reasons, our own waste actually increased. Does it mean we are the person doing it? It happens in the house. All right. Maybe something happened and eventually you are the one at the spot. Doesn't mean I'm the one that did it. So, Claire, I think you said something. For a week, and labels the bin with a class. Now I'm going to each class and find how much waste on the floor or table or anywhere, to be honest. Okay. For a week, and label the bins with a class. Okay. So now, if we label the bins with a class and we check that for 1 week, so from there, we could now pick the result of the people picking producing the most waste. Is that what you think, Claire? Is that okay, Claire? Okay, that's what you said. Okay, beautiful. So now let's see what we could do. I love your idea about a week, but for some reasons, I don't think a week is enough. Because there are tendencies that it might be that a lot of things are factors we need to consider. There are variables we need to look at, all right? Few weeks, okay? And aside, Claire, for your own view, we might decide to calculate all of them. And for example, after the calculation for 1 week, we now saw that the majority of the waste is coming from young innovators after calculating the sum. But there's something else we need to look at. I don't know if I'm making sense now. There is something else we need to observe to actually see what happens in 3 weeks' time. You might check now, it might be these people, innovators, and after some time, it changes to the other guys. So how exactly do we measure this particular problem so we could get the best evidence? If you are still with me, type I'm with you on the chat. If you are still following till now, can you type you are with me? And I hope you are thinking. Yeah, I hope you are following. Good, you are with me. Beautiful. I'm with you. Beautiful. Start thinking how we can measure this without causing any problem and without calling the wrong people. Are you there now? Without calling yeah, thank you, Kamsi, for following. Yeah, thank you, Chukwemeka, and everyone has commented. So let's keep going and see what we could do right here. Now, we are going to use mathematics. I love what Claire said. We're going to dive a little bit further on that. So, Claire, I just want to hear from you because you said that it is possible for you to on your mic. I want to kind of, sorry, let me turn the noise in the background. All right, sorry, I need to tame the noise in the background, please. Okay, so let's continue now. So, how do we bring mathematics to life? What can maths do for us at this point? Confirm you can hear me loud and clear, please. Confirm you can hear me loud and clear. Okay, beautiful. So, let's see what we could do. Now, one key thing we need to know is that mathematics will come to work. But before then, yeah, Claire, please, I wanted to say something before I lost my line of thoughts. Please, if you can on your mic, can you just tell me how you're going to go about that for 1 week and pick the class you want to pick? So let's see how everybody pay attention to what Claire has to say, and let's see how we could solve that problem. So Claire, the stage is yours. In a few minutes, please. Everybody pay attention. Yeah.
So around the school, like you put the bins and then like you label it with each class and tell them to put the rubbish in only their bins. And then at the end of the week, like you collect all the rubbish from like each class and you see like how much each class is given and you see which one has the most.
Okay. And then with that, we can say, oh, these guys are responsible. Can we clap for Claire, please? Yeah, I love that idea. And then we'll move DPR. Thank you so much for that. All right, so let's navigate. Thank you. That's for you. Beautiful. So let's proceed now. So let's see what maths could do for us so that we ensure we are making a decision that will help us even to ensure we educate all of them. Joshua, sorry about that. So let's look at what we're going to do. We might not finish it today, but let's have an overview. So number one, we are asking questions, right? We've asked questions. Which particular guys are responsible for it? That's the first question we are asking. Which guys are responsible for this? Now, when we ask questions, we'll go over to what Claire has said. We now observe carefully. Are you seeing it now? We'll start to observe. That's the same thing that has to do with solving problems. You ask questions. The moment you ask questions, that is where you can start thinking about solving a problem. You see some things not going well. Why is this thing this way? Without asking questions, problems cannot be solved. So we ask, why is this thing happening? Why is it happening? Even if I get to realize that these young innovators are increasing this waste, why is it so? What could be the problem? So we are asking those questions, you begin to observe carefully. And when you observe, that is where measurement comes into place. That's the first step. Ask questions, observe carefully, then you measure. When you measure, like Claire said, you now check the quantity. But remember, there is a fourth step that has to do with we record the data. You have to do that with numbers. That is maths now. You have to do that with numbers so that you can accurately defend whatever thing you are saying. Just like what we said is young people, is this one more numbers, you have to be able to defend whatever thing you are saying with an evidence. And that's how we said it is mathematics that will give you the evidence that the question is seeking for. Now, after that, you now analyze the data. When you analyze the data, that is when we could now make decisions regarding what we've actually worked on. So good decisions begin with good evidence. And mathematics helps to give you that evidence that you seek. And with that evidence, we are good to go. Now, I had a mission brief of what I want to carry out. I decided to investigate the waste, like Claire said, produced by every class, every school day. And I'm going to do that for 2 weeks. 2 weeks is even very short. I can even do that for a month. But for this class, let's just look at them for 2 weeks, just like what Claire said in 1 week. But there are other factors we can add to what Claire said to modify to ensure that we make the right decision at the end of the day. If you are still with me, can you give me a thumbs up? If you are still following, I need a thumbs up from you. So that helps us to make a right decision. So ensure that when you have something to do in terms of decisions to make, or you see a problem, be very good at observing, and then you ask questions. Now, let's see what happens when we start collecting data. Now, we applied what Claire said. Let's put the waste bins in each class, from the young innovators down to the last guy, and then we need to record the data. And to record the data, you don't do that with your eyes, because Claire said we'll now check the waste. With your eyes, you can't tell. I don't know if you are following to this point now. You have to do what? You have to measure. And your measurement should be something that you can rely on. And that is why in school, when you are in year 5, year 4, year 3, that's primary 3 for those in Nigeria, for those in US, grade 4, grade 3, grade 6, in those classes, they began to teach you about the unit of length, the unit of weight, time, conversion. You are not just learning those things because they want you to pass exams. You are learning those units and measurement because you are going to need them in solving problems. So for this problem we're about to solve, we need the knowledge of weight, which will be in kg or in gram, as the case might be. So all of those lengths and measurements and units you learned will come to work here in terms of measurement. So we're not using our eye to say, oh, these people's own, someone said the ones that get fueled first. The other people said the ones that get fueled. Now, I think that was what Prosper said, the one that gets fueled first. But it doesn't work that way. You have to use numbers. So let's see what happens as we begin collecting this data once we place the different bins, like Claire said, in their classes, and then we'll measure. Now, in measurement, we bought a scale, a weighing balance. You know that scale we use. Some of them might have something circle and have something that, you know about a scale, right? Your beam balance, all right? You know what I'm talking about, right? On the chart, you can confirm. You have your weighing balance, okay? So, are you following me till now? Are we following till now? Are we following? I hope I'm not alone. Yes. Yes, Chukemeka said yes. Beautiful. So, you understand the balance, the weighing balance I'm talking about. So, every single day, I called out my team. I said, okay, these are the team members. Okay, Prosper, Chukemeka, Jane, all of you will serve as my team members for each of these classes. So every single day, get that waste, put that on a weighing balance, and record the weight. Record the weight. So this was exactly what we had for each day. On Monday, we noticed that young explorers, the weight of their bin was 5.0. It could be kg, it could be gram. You can record on kg and later you convert to gram. You could record in gram and later convert to kg. The measurements you learned back in primary school. for those that have left primary school, and for those that are still there, you are learning some of those things. Pay attention to them. Now, you look at young innovators, what they have. Now, let's study this table carefully before we say anything for week 1. Now, observe the table. And I want you to tell me whatever thing you are seeing from this table. What did you notice? Are you studying the table carefully now? What are you studying? Look at it very well with your 2 eyes. Observe that table and see what that table is telling you. There is something I want to hear from each of you. And I know some persons are going to rush to a particular thing. Yes, that's an angle. But deeper than that, there is something else I want you to look at as you're observing this particular table. So, have you studied the table now? Have you looked at it? As you are studying that now, you can write down what you're observing from that table. If you have a paper with you or your phone, you could type out your observation from this table. Are you doing that, guys? Are we there? Type out your observations from this table. Are we done writing? Can I move to the next slide? Are you done observing? Everybody, are you done observing? Can I move to the next slide? Jen said no. Gochku said yes. Chidben Proper said yes. Oh, okay. Sharon said yes. Kamsi said yes. Every other I want to see your yes before I move. Adebisi said yes. Everybody, I want to see your yes before I move. Observe the table from the young leaders to the young innovators, from the future leaders, from the every one of them. Observe it very well. Okay, now, if you are done observing the table, now I want to hear from you. What did you observe? Type on the chat. I need people to type what they observed from the table. If it is more than one, you can type the chat once before you send it. Number 1, you type. If you want to press enter, you hold the shift button. Let me check if it works. You hold the shift button and you press enter. It goes to the next line. So you can type everything at once, so we can read it out. So question, the number 1 observation you type, you write, then you hold your shift button. If you're using what do you call it? If you are using Windows, all right, your normal PC. If you're using PC, you make use of that. I don't know for Mac now. Mac, I think for Mac, is it my person is not here? Is it command key or the control key? I can't remember. All right. So the young leaders have produced the most waste the whole week. Okay. Young leaders produce the most waste the whole week, but there's something else I want to see. If you're using a Mac, I don't know why you guys call that button again. And next person now, another person. Another person now. The amount of waste the young leaders make decreases as the week goes on, while the young innovators' waste increases. Beautiful. Now, good. So the amount of waste the young leaders makes decreases. Okay, good. As the week goes on, while the young innovators, young explorers' waste increases. That's from Cheesy. Good. The older they get, the more they waste. Okay, but that's your conclusion is not too right, Mugochukwu, Nicholas, because there's something happening for the future leaders. It is for future leaders, the trend is not okay. The older they get, the older the class, the more waste they produce. I disagree, because if you check here, that is not really what is happening here. The future leaders alters that particular thing you said. Cheesy, I agree with you. Young explorers decrease by 0.2 each day. You are bringing in mathematics now. Beautiful. Chukemeka said young explorers is increasing by 0.2 kg daily. Good. Now, Kelly, I've not seen your own answer here. I think I'm seeing answers here. I'm here to see your answers here. Nicholas Ugu, I'm here to see your answer. Ayode, that's Lade. I'm here to see your own. Abigail Ugu, I'm here to see your answer. Tim Harinda is here above you. Come see, how are you? What are you seeing on that table? Look at the table and tell me something. And then you see Sharon, that's Ayofe. I'm here to see your own responses. What's happening? Okay, now, so I don't want you to jump in by looking at the number total, because if you don't observe the trend, you have to pay attention to the trend. Eventually, you've said something about the young leaders producing their most amount of waste. Yes, they are. But observe something. If these young explorers continues this way, don't you think that something could happen over time? Because these guys, their own is reducing gradually. Are you seeing it now? Young innovators, their own is decreasing. That of young leaders group, their own is also decreasing. In as much as it happens that they have the total waste at the end of the week. But observe the trend about the young leaders, the young explorers, and the rest as time goes on. If you are still with me, type I'm with you. If you are still with me, can you type you are with me? I'm with you. Beautiful. I'm with you. I'm with you. Beautiful. Good. So start thinking so deeply now. So you don't just run into conclusion with just the fact that at the end of the week, this guy's own is more, and you jump into conclusion. We don't work that way because the trend you are seeing is teaching you something. I might not have the total today, but if those guys continue with that rate, something might happen over time. So let's see. I now said something right here. I said, what did you notice? And you guys have highlighted what you noticed. Which class appears to produce the most waste? Yes, it happens to be the young leaders. Now, does any class seem to be improving during the week? Some classes are improving. You could see that explorers are improving every single day. You could see that the young innovators are improving. Sorry, they are not. Which one are not improving? Sorry, young explorers are not improving, but the young innovators are improving every single day. Future leaders are also not. It goes up. Those guys are just careless. It goes up, it goes down. So they're not even doing anything. They're just in between. We have the young leaders. Their own happen to be a bit higher, all right? But then something is happening. Also, do not neglect the size of the class. Don't also neglect the size of the class. The size of the class also plays a role. So imagine a class that is smaller, but then producing a very huge amount of waste. It is something of concern as well. So you don't jump into conclusion just by 1 week. Now, let's go on to week 2 and see what happens in week 2. Now, can I proceed now? But before then, I thought I had to, let me just have a little break on this before I move to the next thing. And I have to think about something. Why did even people invent tables? And remember that in school, for those of you that are doing some of things on your plotting of graph and the rest of them, you need a table. So why are we stressing ourselves with a table? Without that table I had right there, so imagine I just came, I look at the waist and say, oh, this one is small today. Tomorrow I look at it again, your own is small. So after 1 week, how will I keep track? So that is why tables are very important when it comes to mathematics and making decisions. And that's why they stress you in school to draw your tables and the rest of them to keep things in track and to keep whatever observation you're making on check. And that's the same thing I want you to do aside mathematics. When you're working on a particular thing, have a table where you keep note of some things. That's where you stay organized. Not by saying this one happens, this one happens. Let that be where you keep track of things. So imagine I was using my eyes to track all of these things. It becomes a problem. So you are seeing that the maths you are learning in school, it has a real life application, even in the way you organize your life as a person. If you are following, type I'm following on the chat. I go to the next slide. So when you have good organization, it will turn your confusion into clarity. And clarity will lead to a better decision. Are you there now? So when you organize, it brings about clarity. And with clarity, you can make better decisions. All right? And you will have a better evidence, just as we have from the first table. But as you observe something, you would see that that table is not enough at the moment. We need to do more before we come to a conclusion. Now, the next thing we could do as people that want to use mathematics to solve problems, I now ask you a question. Should I make a decision now? Should the generator decide after only 1 week I make a decision? No, I shouldn't. Yeah, it's not okay to make a decision. And that is why, for some of you that have done your probability in school, in probability, you have the number of trials. The more you increase the number of trials, what happens? You come closer to the results. The more the trials, the more accurate the result is going to be at the end of the day. If you agree with me, you also type I agree on the chat. If you agree, type I agree on the chat. Good. Good. So we don't judge with week 1. We repeat our experiment. So you are beginning to see why, in terms of your probability, you keep doing over and over again. And that brings about your precision and your accuracy. There's a difference between precision and what? Accuracy. And that is why we have to keep repeating the trials and then consider how precise the result is and how accurate it is. All right. I agree. Beautiful. I concur. Very beautiful. So let's continue and see what to do after week 2. So, Engineer Lota decides that after week 1, I have to do more, because investigations require patience. You have to observe and observe until you are sure to come up with an evidence. So I told the cleaning team, please continue to weigh this waste every single day. Weigh it every day. And then label the bins. And I kept recording my measurements. I kept measuring my measurements. Now, let's see if week 2 will confirm my assumption, or will it change the story? Let's see what happens right there as time goes on. Now, let's see what happens. Remember that I'm painting pictures of 3 problems that could happen. Now, we went ahead for week 2. We also have the results for week 2 as well. And in week 2, you could as well see that for the young explorers, it is as well increasing. Young innovators, it is still decreasing. Future leaders, they are still moving up and down. I don't have anything to say about those guys. And for the young leaders, their waste is still high, but they are reducing it every single day. Now, let's compare with that of week 2. Is any class improving? Is any class getting worse? Are your first opinions still the same? Do you have the same opinion with these guys as time goes on? We are observing a trend. We are observing something that is happening with our week 1 and week 2. Now, because of the fact that we don't have so much time, I decided to stop at week 2. Are you seeing it now? And I feel that with week 1 and week 2, I could have something. When I was planning this particular experiment, I said I'm going to do it for 1 month. But I realized that 1 month, if I do the table for 1 month, we might lose track of the data. So I said, let's stick at what? Just 2 weeks. Are you seeing how the tables are coming through and how you're beginning to apply your math to solve just one problem of realizing who is actually doing this? That is the same way we calculate the electricity consumption, and we say that, oh, in UK, this particular side of the city consumes more electricity. They didn't just wake up one morning and say that it is London that consumes more, or it is this side, it is Leicester that consumes more. No, you work with data, and you have an evidence that says that, oh, because so and so thing, we've calculated this and this, London consumes more waste, more electricity than Leicester. Are you seeing it now? Or than so and so particular place, you know. You don't just say things without an evidence. So let's continue. Now, we now have a comparison between the 2 data that we have, week 1 and week 2. And with those 2 data, we could say this class has improved. This class has become worse. This class has stayed fairly consistent over time, improving. From here, some persons gave me things about percentages. Very beautiful. You start thinking about percentages. Percentage increase, percentage decrease. All of those skills are very important to solve this problem. So I can tell the young explorers, hey, young people, for this particular week, you guys increased by so and so. The waste decreased by so and so. The average of what you've done so far is this and this. You have a real data that can be tracked over time. Still with me, give me a thumbs up. And I hope we're making progress. I hope we're making progress. All right. If we're making progress, I concur with me on the chat, just like Chukwemeka said, I concurred the last time. Now, I concur. Thank you. So, I wrote something here. We now have more evidence, but is it becoming harder to see the whole story? Can we see the whole story 4 months from now? Can we see the whole story 1 month from now from this data that we have currently? Then there is something else that we need. And what is that we need? I'm asking another question now. Did people invent graphs just because of mathematics exams? Are we learning how to plot graphs just because we want to plot the linear graph y equal to mx plus c? Because this, and this. Then you are learning, oh, Mr. Lota, I don't want to learn how this graph is tiring, plotting these graphs, they are disturbing me. No. Now, if you observe something, the graphs will make the whole thing easier for us to see better, at least during the weekdays. And then, because we can't keep looking at that table the way it is, now, the graph will help our brain to see the patterns that the table is hiding. We could use your bar graph, even your bar chart, I mean, in as much as your bar chart will not even give us what we need entirely. Are we there now? We can't actually see. Can you now see immediately how difficult it was, what you couldn't see from the table? At a glance, you can now see from bar chart. And let's look at what we have right here. Now, from the bar chart, we're just looking at it. You have the total from the bar chart already. You've seen the class that produces the most waste, or the most waste, as the case might be. You can compare, but then there are still details that this bar chart cannot give to me, that I need to analyze through something else, which is your graph, the linear graph, the quadratic graph you've learned, some of you have learned, or some of you will learn as time goes on. Those that are still in primary school, you're going to learn all of this. So when you start learning them, don't think they are stressing you. Never you think that, oh, these things are boring. They will help you in making decisions and in solving problems. That is why I said the maths we are doing today is not the kind of maths everybody was expecting. It is a maths that will cause you to think and solve problems better. Now let's continue further. Now we have our bar chart and everything in that. I have another question right here, Breggen. And I said, but wait, does this particular chart, does it tell me everything? From that particular chart, can I tell people that are improving or getting worse? Can I see the changes that happen over time? Yes, it could compare what I have, but it doesn't actually tell me the whole story over time. Can I now predict what will happen 3 months from now? With the bar chart, can I do that? Can I predict what can happen 3 months from now using the bar chart? No, I cannot. People are saying no. Yes, I cannot, because the bar chart just tells me this is big, but doesn't go into details. And for the table, if I keep getting tables, I might lose track because it's becoming so much. Now, can we have another graph that can review what the other one cannot? That is why in school you learned your bar chart, you learned your histogram. For some of you that have learned it, people that have not learned, I think this thing is building the curiosity in you to go and learn. If you've not done that before, for those that have learned it, you could see how you could use some of those things to solve your problems that you don't know how to navigate about. All right. Now, because our brain needs help with going through all of these things to know what is happening, we need something better than the bar chart or even the pie chart, as the case might be, or your histogram. We need something that will tell us what the trend looks like over time. Now, what could this trend be? I now look at the graph. The graph tells me something. With this graph, I can calculate the gradient. Sorry, for the younger persons in the house, it's fine, and I hope you are still following. Now, you start calculating the gradient. Why are you calculating the gradient of the line? For those in Nigeria, we'll call it slope. Easily, we'll call it slope easily, you know. So the gradient of the line, what does it tell me over time? So young explorers, your waste is increasing. In as much as the young leaders might have the most number of waste, which I don't really know what will happen 3 weeks from now. If you keep increasing this way, does it mean that it will get to a point where the young explorers will produce more waste than the young leaders? I don't know if I'm making sense at all. Am I making sense in the house? Am I saying something that is true? Am I making sense, guys? Good. Amanda, thank you for the thumbs up. Jane, thank you. Okay, Ketru said you are. Beautiful. I hope I'm making sense. Good. He said, Jim said yes. Claire, give me a thumbs up. Beautiful. So we don't jump into conclusion. Do you know what this thing will help you do? What this thing will help you do is that I don't just go and attack young leaders. Young people, you guys are producing waste in this school. Anytime this thing happens again, I will do this, I will do that. I will attack the young leaders. Now, 3 months from now, the same problem will happen again. And I will still start stressing myself to start measuring again. But when I make the right decisions, I could tackle the problem from the roots. I know where it is coming from, and I know those I could address. Look at the future leaders. Did you see what is happening here for future leaders now? Are you seeing something? Those guys, the trend is very funny. It goes up, it goes down. I can't predict these guys. So which means I have to call these future engineers. Oh, young people, it might not be you guys producing this waste. But if I leave you guys for some time, there will be a problem in this school because you guys are going up and down. Young leaders, I can see there's a drop in your waste. It is dropping. Young innovators, I could also see your waste is dropping. Now, for the young explorers, you can see that the waste is going up. That's that straight line going this way, a positive graph. This is a positive graph, and we know that a positive graph should have a positive slope, a positive gradient. For these guys, it is decreasing over time. Now, I can't even determine the slope here because the slope is changing, more like for those that are in sciences already, more like when you have non-uniform motion. You have that non-uniform motion, a car moves and stops and keeps again, just those particular pattern over time. Now, from these conclusions, we are here to draw a conclusion, we are here to make a decision, but yet we are having a view of how, remember that these graphs are plotted. You can use, for me, I use a particular tool that plotted the graph for me from that data. But in school, they teach you how to plot those graphs because they know that the scale is very important. You start picking things we call the scale and the units. For those that are coming up, you are going to do that as well. So when you see the elderly ones going around with the graph book, this is what they are trying to do. They are not just trying to pass an exams. They are trying to understand a trend that will help them solve a problem. And that's how the people in the world as well solve some of our problems. So I said something. The linear graph helps us see how things changing over time. All right. And if that is the case, let's see what it does reveal to us. In as much as I'm yet to make a decision yet, but it's giving me an idea of the decision I might make over time. So let's move to the next slide and see what happens next. Sorry, the slide has not moved. What could be the problem? Sorry, I think I need to reduce it again. Yeah, it has to move now. Good. Now, young leaders, shouldn't Engineer Lota be concerned with the young explorers? Young innovators, what might they be doing differently? For the future engineers, why might their waste go up and down? I used to I'm asking more questions now. I'm asking more questions. One question is leading to more questions. The question I started with was, who is producing this waste? But the more I started measuring them, my question is changing. Now, for the young explorers, I'm concerned already. For young innovators, what do these guys know that others don't know? For future engineers, what is this people's problem? Why is it going up and down? Now, young leaders, is our first assumption correct? The assumption we made that these guys are producing the most waste. All right? So we're moving, we're making a progress as time goes on. Now, that said, we go to the point where 5 weeks from now, what will this thing look like? From the graph we are seeing now, can we predict something that in 3 months' time, see guys, this will happen in 3 weeks, this will happen in 3 months. What line will probably continue rising? What class needs immediate support? Which line will probably continue falling from a trend you've noticed? Which class could mentor another class? Now, prediction is not guessing, like I said, very important idea. We predict the weather. They tell you in 3 months' time, the temperature of the United Kingdom is going to be this. In 4 days' time, we are expecting heavy rainfall. In 3 days' time, we are expecting that there's going to be a heat wave. In 5 years' time, we're expecting that there will be more wildfire in so and so place. They are not just saying, it is not prophecy. They are not prophesying. They are working based on data. Prediction is not guessing. Prediction uses an evidence and a pattern to estimate what can happen next. So when they say those things, they don't just wake up. My people, they don't wake up, they look at a pattern just like what we are looking at today. And remember that the pattern we are building now is coming from a question that we asked. A simple question we asked is becoming a pattern that will help us predict things as time goes on. Now, our decision today, we're not going to make the decision today. No, we will not do that. By tomorrow's class, we should look better and see how best we can make decisions on this. But before then, I want us to navigate through these things together, all right, and see the data in full. I will share my screen now, so you see the data in full and how we can as well look at the percentage increase, which some of you have said already, and see how best we could navigate through them. All right. Now, from what you've seen so far, which people do you think will continue doing well from what you've seen so far? Which guy do you think that, oh, these guys will keep getting these things right even 5 months from now? Can we hit our chest and say that? Are you with me at all? Are you with me at all? Oh, I think I've lost a good number of you. You guys are no longer with me. Am I saying things that are just vague? Things that looks, I don't know. Okay. Bamis, are you still on the call? So can we say something from there? Because in our next class, we look at how we can now make a decision. In as much as we are seeing some things there, we might not label, oh, young leaders, you guys, I should look into you guys. But even as I'm looking into you, there are other things I might observe to see how it flows. Is that okay now? So let's look at the results real quick and see how we could navigate through. And then I call us up to say a few things before we call it a wrap for today's section, because maths class shouldn't stay for that long. So let me share my screen right away. So confirm when you can see my second screen and let me know when you can see that. All right, so I'm sharing my screen now and then we'll move. Yeah, confirm you can see the screen now. Good. The other one is out. Confirm you can see it. Okay, good. So this is a layout of the results that we have. More like a layout of everything, very clear, the way it should be. We had our week 1, and then we moved on to the week 2 timetable. Sorry, the week 2 results. We had this as well for the table. Now, sorry, I'm going back. We have for week 1 and 2, comparing the both of the two data together. Then we have our week 1 total. On an average, you could see the amount of waste these guys are producing on average, 11.5 kg. Now, this average will help us do something. Can you see my question now? This average will help us do something because these guys are increasing. And I have to pay attention to the average. Remember how the average was obtained. We add the number of waste they produce each day and divide by the number of days we have. That's how you get the average as always. So the mean data, the mean numbers, 5 days in a week, and the total divided by the number of days in a week. That is what we have for the week 1 total. And that's the average. You could see that each of them are producing every single day. Now, we can compare them using our bar chart for the young leaders, young explorers, young innovators, future leaders, young leaders who have their bar charts compared right here. And I could see everything happening on a regular day. Then, with this, I can calculate the percentage change for each day. That percentage change could help me predict what happens in 3 months. Because you observe a trend, is as though that's where you start learning about sequence. So in school, when you're learning about sequence and patterns, they are not stressing you to learn Fibonacci sequence and those triangular sequences you are learning. It is for you to develop the creativity to be able to make this kind of decisions. So the next, you have the young explorers here for the individual and the total. This is the total we have. So individually, that's what they have for the week 1. Now, this is your week 2 total. These guys are still topping, but observe something. Observe something with the week 1 total, week 2 total, and week 1 total for the young leaders. Let's go back. Here it was 51.7. Young explorers was 31.5. Now look at something now. Let's go back to the other total. 7.1. Are you seeing the decrease? You can even calculate the percentage decrease for these young leaders. The way it is dropping. These guys are coming up. So we have to make a decision of what happens in 1 month's time. Eventually, these guys might even top these guys. But all those things we need to solve So let's proceed. I believe you are seeing the data, the comparison, and how we could make better decisions without jumping into conclusion. That was the graph I showed us earlier about the increase. So you can look at the young explorers, they have 16% increase for the young explorers. That's the trend in week 1, 16% increase. For the young innovators, they have 5.3% decrease. For the young leaders, they are decreasing by 8.3. For future engineers, they are increasing by 2.5%. So these percentages, you need to take note of that. Am I stressing you? Am I stressing you too much? Am I saying a lot of things, guys? People in the house. No, Ikechukwu said no. No, but you said no. Okay. Okay, Bamse said no. All right. Everybody's following, right? Good. Everybody's following. Yes, good. Thank you. So let's proceed. Now, that said, we will look at the week 2. Please follow the trend now. Follow the trend. Follow the trend. Follow the trend. So the trend, young explorers 16% for the week 1. Now, innovators see the trend. Let's see what happens in week 2. Young explorers 13.6, innovators 5.7 decrease, future leaders 1.1 decrease, young leaders 8.3. Now remember that even in real life, it might become a bit difficult to even see the trends in terms of the kind of things you have. All right, sometimes it becomes a challenge. Nicholas, we hope you are following. Abigail, okay, Abigail's on the call. Good. So let's proceed and see what happens next. So young explorers for week 1, you can see it very loud, bold for you to see what is happening there. And then young innovators, you could see it, young leaders and everybody. So only group with the trend going up, decreasing steadily all week, up and down, no clear trend, highest volume still falling, and the rest of it. So let's proceed. For week 2, that's the summary of what we have. Those summary will help us make a decision at the end of the day. So track your data and write it down the way they should. So it makes everything easier for you. Remember how we calculated this percentage change? You look at the value you have on Monday minus the value, the final value minus the original value divided by what? The Monday value times 100. That gives us the percentage change. You learned this in maths already. So that particular mathematics you learned is what we're applying right here to get the percentages, and we keep track of them. So, and we have a comparison of these two data. So now, when we come tomorrow, we'll now see how we will now make decisions. And we use this to predict for 2 months, use it to predict for 3 months, and then come to a conclusion about the kind of things each of them could do, and we advise them accordingly. Are we all together, guys? Now, did you follow up until this point? You followed to this point? Did you follow to this point? Ikechukwu thumbs up, children thumbs up, Ugochukwu thumbs up. Beautiful. You follow to this point. Makes sense. Makes sense. Now, like I said, tomorrow will be more of the decision making. Okay. So even when you start producing some of that your products, it's important you keep track of the numbers. For example, some of you that want to start producing, I don't know the product, somebody said Eco Bricks and the rest of them. You have to keep track of something. What will you keep track of? For every raw material, how much raw material was consumed to produce a particular thing? Now, I know we've said something about using this eco. Some of you said a lot of things. In that product you are designing, you have to think. Now, for each raw material, what am I producing? You cannot, for example, consume a raw material, let's say about, just a vague example now, 1,000 kg of a particular raw material, and you are making just 2 kg of a particular product by consuming 1,000. That your company should be closed down because you are consuming more than you are producing. I don't know if I'm making sense. So while building your project, take note of the numbers. Take note of the numbers. What are the quantifications you are making? What are the predictions we could make? For this certain amount of product of this particular raw material, that is what I'm expecting to produce. Now, I will factor in some of the things that might happen. Like in this particular case, we can factor in the number of students. So the young leaders class, I think, has a more number of students. So if I compare the young leaders class with their number and the amount of waste they are producing and compare with young explorers, I can't hold the young leaders responsible because they are more in number and their own is even decreasing compared to the young explorers that had little number but then has more waste. So you think as you design your product. That is what the mathematics will do for you as you navigate through the project. So for different industries, I think keep submitting your project. I'm here to look at those things you want to do, but look at them. And also, as you are doing those things, please put that into consideration so that when you come during the day you are presenting your project, I might ask you during the presentation of your project, you said, I want to produce this and this. You show me whatever thing you built on how to do this and that. But I want to know how much of this will produce this. Hope it's not confusing, guys. Is it confusing? Are you thinking now? Are you thinking? Confirm if you are thinking now ahead. Hope you are thinking ahead. You could use the chat. I believe you are thinking ahead on what to do as time goes on. I hope you are thinking ahead. So, ladies and gentlemen, tying everything we've learned together from the green innovation track where you saw the problems to the mathematics track where we measure the problems. Now from next week, Monday down to Saturday, you start now building solutions or technologies that will help you either amplify it, talk about what you do, or have a technology that says something about it. It all begins with you doing your calculations. So from today, I want to have a different perspective regarding mathematics. That is why we created the mathematics track, so that you start seeing mathematics differently. You saw how I applied that to solve a problem that I have, which I'm yet to get a result at the end of the day. But by tomorrow, we should conclude and have our result from the end of the whole thing. So that is the way you could see mathematics every single day and fall in love with it, because it helps you see trends and make your decisions. Do I have any questions today? Anyone that has a question you want to ask, please go ahead. The time is now. You have questions, you have contributions to make. At this point, I want you to turn on your mic. If you have questions, you can type on the chat, then I will call you up to the stage. Anybody? Is this next week we are going to be in that space? Yes. From next week, you go to your specialization. I say if you have question, type on the chat first. Let me see what you want to say before I call you up. So yeah, from next week, you go to your different tracks. But some of you, your parents covered for the whole specialization tracks, which means you are attending every single day and you are exploring all the tracks. All right. And I think it's very beautiful for you to explore all the tracks. But then it's also good to go into a particular track and get the work done. Any other question? How about contribution now? Can I have contributions from you? I think I need that contribution. Should I call names? I should call names for the contributions. Joshua, you know you don't hear instructions. Type on the chat first. A simple instruction. Type on the chat. And don't stop studying us by raising your hands up. Type on the chat. Your chat is here. All right. So what I'm currently doing now, I need contributions before we call it a wrap. I have a question about grapes. What's grape or graph? Is it graph you want to say? Okay. And that is Josiah, right? Okay. All right, so go ahead, Josiah, now. You're on the stage.
So I thought that's a bar graph because it like shows us how big we are and how our impact is in evolving.
Yeah.
I
Yeah,
didn't
right,
get the last bit you said, by the way,
about what?
about the quiz on Friday.
Sorry, about what? I can't hear you.
The quiz.
The quiz, okay. I said for the quiz that we'll be writing a quiz tomorrow. Immediately after making a conclusion from our results, make a decision from the results, that we'll have regarding the mathematical problem we've stated. So from after that, we'll now enter into the quiz where we'll look at everything we've done before. You answer questions based on things you've done in the innovation track in preparation for your specialization tracks. Is that okay?
Yes, sir.
All right, good. I hope that may answer.
Yeah.
All right, so the floor is open for contributions now. I don't want to call names. I want you to contribute, and then we end for today's session. While I see you tomorrow. Well, I think, should I give an assignment? What if you go home?
No assignment, please. If we have a quiz, please, no, please.
All right, so I think I should give an assignment. Now, this slide will be sent on the dashboard. So from this chart, I want you to see what you could predict from it. Now, let the prediction be for the 4th week, or the conclusion you could make. Yeah, I want to draw a conclusion from that result and tell me the people you are calling to be the people producing the most waste. And that should be a 4 weeks conclusion. Just try to look at the data again. I know not everybody could do that, but then I'm giving you an extra task. Just look at the slides, look at the people producing that extra waste. Which book are you going to hold responsible after 1 month of studying the problem? Which guys are you going to hold responsible, and give reasons for that? So tomorrow I'm going to take your presentation. I'm going to pick just 3 people that did that. So I want to see what your predictions are. I want to see what your conclusions are, right? After the 4th week or something. Just look at the data, see what you could actually say about it, and then let me see your conclusions at the end of the day. For those producing the most waste, the advice you could give to them, what we could do, and the rest of that. I'll just pick, let's say, 2 boys, 2 girls to present their solutions tomorrow before I will now draw a conclusion from our own results, and then we'll take a quiz. All right, so I want to call just one person, just for a contribution so far, for the mass track. Who should I call? Nicola. Okay, I've not heard Nicola's voice. So I'm calling Nicolas Ugu. I want to hear from you. I want to hear contribution from you based on the mass track you just did today. I want to call I've got Nicolas. I want to call Ugochukwu. Ugochukwu. And after Ugochukwu, I want to hear from Chukwuemeka. Yeah. So I think I have 3 persons I want to hear from now. So Nicolas, you ready? Nicolas, are you ready? Give me a thumbs up if you are ready. Nicolas? Nicolas, oh yeah, Abigail, over to you. Come on, deliver your brother now, Abigail. Abigail, over to you. Yeah, one of you must say something. I've not heard your voice in the class for a long time. So one of you, I want to say something. Either Nicolas or Abigail, Ugu, I can see you on the call. So while they are waiting to do that, Ugochukwu, over to you. Your mic is on now. So I know this is your 2nd class, so at least you stayed at the mass track with us. So I want to hear from you. Just one key thing from you. And then I take, yeah, the stage is yours. Let's hear from you. Ugochukwu, are you there? That's Nicolas. So I see what is happening. Everybody's keeping quiet. The mic is off. No, Ugochukwu, I've on it now. Go ahead and check. Turn it on now. It's on.
So
All right.
I've learned that like you have to like look at the possibilities and like look at the different sources, like how people are in a class, and then like make like a graph from that and like a conclusion.
Okay. A conclusion. Okay. I think I will just take what you said. All right. Okay, that's fine. Who again did I mention? I think you said something. the Ugus have refused to talk in the class. Thank you, Nicholas. So Chukwemeka, over to you now. Thank you, Nicholas. Chukwemeka, over to you.
So, are you hearing me?
Yeah, we can hear you.
Okay, I've learned that it's good to calculate and good to actually, solve problems. Actually, that's all I've learned today. To solve problems is good to not only to know math, but to know math as to a level you can do to solve problems. You can use to solve problems. So that's all I've learned.
Okay, beautiful.
Thank you.
Thank you. Yeah, welcome, Chukwemeka. Glad to hear that. Glad to have that. Okay, so that said, please continue the project I've given to you and have enough time to revise whatever thing you've been learning so far as you take on your quiz tomorrow. All right, since you don't have any questions for me, I think I'm free like a bird to end the session here. Yeah, I think I'm free like a bird. Am I free? So tomorrow I'll draw the conclusions for us tomorrow, but then I need to have 3 persons that will work on that. So can I have 3 people that are on the chat that will tell me I'm going to work on it so that tomorrow I call you up? How many persons work on that? How many persons work on that? Indicate on the chat. How many will work on that? Me. Okay, Jane, I trust you. Chukwemeka will work on that. I trust you. I will try. Kamsi, me, Ikechuku, I'm going to work on it. Okay, Tizi, I trust you. Chimarida, I trust you. Okay. Why is it that I have more of the ladies saying that they're going to do it? I have more. Nnamdi, where are you? You're not going to do it. Huh? Where are you? No, you have to do it now. I will try. Okay. Masoko, that's Mary. Will you do that? Adebisi, will you do that? Bami say, you've not said anything. I will do it. Okay. Claire, I did this assignment at all. I've not seen any of your assignments, Claire, including the document. I'm not. So yeah, Joshua, I know you. I know you won't. Okay. So I hope so. Let me see. So I explain it again. When you watch the recording, you're going to see it again. Yeah, now when you watch the recording, you get to know that again. All right, guys. So this is where we'll wrap up the session. I look forward to seeing each and every one of you tomorrow while we wrap up the deal that we have, right? Which is in terms of drawing conclusion. We take our piece and then I will explain the different tracks you have and how it's going to look like as from Monday. So enjoy the rest of your weekend and happy Friday, everyone. I wish I can play songs for you now, but then I need to go wrap up something immediately. Yeah, I need to go work on something immediately. So I'll see you guys tomorrow. Remember to do the assignments, come with the conclusions, and I can't wait to see what you've worked on and the different angles you're going to explore. And then I'll end with that thing that Chidibem said. Chidibem said something that let me get that immediately as I round up with that particular thing that Chidibem said in terms of problem. He said, where is that again? I want to end with that thing you said, Chidibem. I want to get that quote. Yeah, I want to go with that quote. Yeah, with maths you solve questions. That's from Claire. And with questions you solve maths. And then Prosper said, since maths answers questions, without questions there will be no maths. And remember, the world have problems, but also the world have problem solvers. So be a problem solver, and I can't wait to see you guys tomorrow. So bye, everyone. So please do the assignment. I love you all. Yeah.